to section 2 of unit 1, section objectives. By the end of this section, you should be able to find 1. The union of 2 or 3 given sets. 2. The intersection of 2 or 3 given sets. And 3. The difference between any 2 given sets. Let us look at union of sets. Let's look at definition 1. Let A and B be 2 sets. Then the union of set A and set B, denoted by A union B, is the set of elements that are either in A or B or both. That is, A union B is equal to the set of X such that X is a member of A or X is a member of B. What this means is that if you want to find the union of 2 sets or 3 sets or 4 sets, all you have to do is to bring all the elements in the sets that you are looking at into one new set. And when you are bringing them together, you are very careful about the fact that those elements that are repeated in some of the sets are not written twice, but written once. This means that the union of 2 sets, for example, set A and set B, is a new set that is made up of the members of set A or set B or both. Consider the 2 sets below. Set A is 1, 2, 3, 4, 5, and 6. And set B contains 2, 4, 6, 8, and 10. The union of these 2 sets is given as A union B, which is equal to 1, 2, 3, 4, 5, 6, 8, and 10. You notice that 2, 4, and 6 are found in both sets, but they are written once in the new set. You can now get 3 sets of your own and find the union of these 3 sets and discuss the answer with your colleagues. Let's continue to look at union of sets, and we will consider an example. If set A is equal to X such that X is greater than -4 but less than 6, and X is a natural number, and set B is equal to X such that X is a positive even number less than 10, find A union B. Let's look at the solution. We have to list the members of set A, and that is -3, -2, -1, 0, 1, 2, 3, 4, and 5. We also have to list the members of set B, and that is 2, 4, 6, and 8. To find the union of these 2 sets, we are going to combine the elements into a new set, which will be given as A union B, and that is -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, and 8. You notice that the elements 2 and 4 can be found in both sets, but in the new sets, they are written only once. We will consider another example that involves 3 different sets, and it says, find the union of sets P, Q, and R. If P is equal to X such that X is a prime number less than 18. Q is positive integers less than 10. And R is X such that X is greater than 6 but less than 15. And that X is a member of natural numbers. Let's look at the solution. And to find a solution, we need to first list the members of each of the sets given. And so members of set P are 2, 3, 5, 7, 11, 13, and 17. Members of set Q are also listed as 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then members of the last set R are listed as 7, 8, 9, 10, 11, 12, 13, and 14. Now we are going to combine these three sets to find a new set which we are calling the union of the three sets. So P union Q union R is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 17. Over here too, you can get your own sets and find the union of same. To continue with the definitions, we are moving now to intersection of sets. Suppose A and B are two sets. Then the intersection of A and B, denoted by A intersection B, is a set of elements that are found in both A and B. That is, A intersection B is equal to X, such that X is a member of A and X is a member of B. So what this means is that you have to look for elements that are common to the given sets, and those elements form what we call the intersection. So the intersection of the two sets A and B will now be a new set, and this new set is made up of elements that are common to both A and B. For example, if set A is equal to 1, 2, 3, 4, 5, and 6, and set B is equal to 2, 4, 6, 8, and 10, then the intersection of set A and B can be given as A intersection B, which is equal to 2, 4, and 6. And so these three elements are the ones that you can find in A and then at the same time find in B. We will continue to look at more examples. So let's consider example 3. Given that set A is X such that X is greater than 3 but less than 9. Set B is X such that X is greater than 4 but less than or equal to 9. Set C is X such that X is greater than 3 but less than or equal to 6. And that all these three sets are subsets of the universal set made up of X such that X is greater or equal to 2 and X is less than 12, where X is an integer. Find A intersection B, B, A intersection C, then C, A intersection B intersection C and D. A union into bracket B intersection C bracket. Solution to the question we looked at. We have to again list the members of the various sets that have been given, and we start with the universal set, and it is made up of 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Then we come to set A, which is made up of 4, 5, 6, 7, 8. Then we move to set B, and it comprises 4, 5, 6, 7, 8, 9, 10. Then finally set C, 4, 5, and 6. Then we come to the first question that says we should find A intersection B. So we consider set A and set B and see the elements that are common to both A and B. We bring those elements together to form the new set A intersection B. And those elements are 4, 5, 6, 7, and 8. This new set can also be written as X, such that X is greater or equal to 4, but less or equal to 8, and that X is an integer. Then we look at the second one, which is A intersection C. This time round, we are going to consider the set A and the set C and look at the elements that are common to both of them. And over there, we see 4, 5, and 6 as the elements that are common to both A and C, which becomes the intersection. We move on to the third one, where we now want to find the intersection of all the three sets, A intersection B intersection C. And so we are going to consider all the elements that are found in A and at the same time found in B and again found in C. And we realize that those elements are 4, 5, and 6. Let's get to the last one, which is A union into bracket B intersection C. We will repeat the sets for A as 4, 5, 6, 7, 8. Then we bring the union, and then we now find the one in the bracket, which is B intersection C. And B intersection C is 4, 5, and 6. So we are now going to find the union of A and the answer we have gotten for B intersection C. And that is 4, 5, 6, 7, and 8. We now look at the last item under section 2 of unit 1, which is difference of sets. The difference of sets is a way of subtracting one set from the other. So that if you have the two sets A and B, and you want to find A minus B, it means that you will subtract from set A all the elements which are in set B. For example, if set A is 1, 2, 3, 4, 5, and 6. And set B is 3, 5, and 6. To find set A minus set B, you will subtract all the elements in set B from the elements in set A, and that will give you 1, 2, and 4. The A minus B can also be called relative complements of B to A, but this should not be confused with complements of a set, which is a set that consists of all the elements not in A but can be found in the universal set. So you take note of the difference between relative complements of B to A and the complements of A. Two different things.